Okay, so we are looking back actually a day ago, which was Monday, May 31st, final day of May. Memorial Day, again, hopefully all of you guys had a great long weekend. But we did have some material that we want to go over. So we're going to be talking about object-oriented programming. This is a term you might have heard of. It's a kind of a buzzy term um, within programming. We're going to be talking about classes, which is a fundamental feature of object-oriented programming. And then we're going to go more specific, talking about instance attributes and class attributes. So hopefully by the end of today, you kind of understand these three concepts. So let's actually just dive into our lecture then. Let's go for it. Okay, so this presentation is making your code classy. Again, just an introduction to object-oriented programming. So this is a slide that I'll use repeatedly. And again, I've mentioned it before and I'll keep mentioning it. The goals of a software developer. So goal number one is to get the correct results. So if a client comes to you and say, hey, I need to solve this problem or have this application, step number one is just delivering something that meets all the requirements. All right, so that's solving a problem, getting the correct results. The second part is the key, I think, differentiating between a software developer and a good software developer. So how do you solve that problem in a better manner? So there's three main buckets that I kind of have created: structurally, functionally, and algorithmically, to improve your code. So by structurally, I just mean better design. And there's various ways we go about doing that. Functionally is just better usability for the end user. So better design is more from the developer side. Better usability is more from the user experience. And then algorithmically, probably the easiest to understand is just how quickly or how efficiently does your algorithm actually run. And this is usually impacts the end user also, because if they're trying to do something that either your algorithm takes an hour or takes a minute, they're gonna care about that. So those are the three main buckets that I kind of talk about when trying to improve your code. So structurally, if you want to talk about that, again, many facets to it. This isn't This is not an exhaustive list, but some areas that you can structurally improve your code. Code organization. So that's going to be the main focus of today, is talking about classes, why they make sense, and why they make your code better. System architecture can be something that impacts your code. So especially for larger projects, you want to make sure you have the proper architecture. So when we talk about architecture, that can mean are you going with a client server model? Are you going peer-to-peer, which is kind of how cryptocurrencies kind of work? Are you going to do a distributed network? What makes most sense for your solution? So that's usually a decision you need to make early on, especially for large projects. You want to determine which architecture makes most sense for your solution. Another concept that I've mentioned before, I think, is future-proofing. So again, there's no exact science to this. There's no way to guarantee what the future is going to hold, but we can anticipate, right? So when you're coding up a solution, make sure it's flexible and robust so that if it needs to change, you don't have to rewrite it from scratch all the time, right? So again, going back to, let's say, our balanced parentheses example, hypothetically imagine that we need to change our algorithm so that instead of just doing regular parentheses, what if we want to add in support for balancing square brackets and curly braces all in one algorithm? How many changes will we need to make? So it's that's something to think about. If we go back to our code, I think we need to make some changes, but I don't think we need to rewrite the entire algorithm. So that's something, again, when you're coding up a solution, make sure it's robust and can change as needed. Again, based on expectations for future requests. So again, just being mindful of what can happen, what the future might bring, but again, you never know what exactly may happen. So just kind of, to your best ability, future-proof your code. Other items that we touched upon: reliability. So this is where we're talking about writing test cases, having safe code. So that's when employing try-catch statements or try-except statements. So does your application crash if something goes wrong, or does it gracefully handle it and pop up an error message? Which of the two do you think is better structurally, right? It's generally better not to completely crash your application for the user, but to gracefully handle errors and make sure that if something does go wrong, that you're able to handle it internally rather than stuff just blowing up. And then simple things like readability. So these are, again, very basic concepts, but all this put together just makes your code that much more structurally sound. So readability. This is as simple as just like, adding comments in your code. Usually I recommend, again, for larger projects, every 5 to 10 lines of code, code blocks that you have, write a simple comment, even if it's as simple as like just read in data file. Again, that's not going to be, I guess it may seem kind of trivial, but as a reader, if someone else is reading your code, it's going to make it easier for them to parse your code and parse the blocks down into smaller chunks. Readability also goes back to naming conventions. Are you following style guidelines? So if you're working on a team, usually you're going to have style guidelines that you guys agree to, and you're going to want to stick to those. I've run into this before where I'm working on a team, and there's if you've gotten into coding, there's two sides of a camp in terms of where should your opening parentheses bracket be. So when you open up a curly brace, some people want it on the same line. So if you're writing an if statement, they want the curly brace on that same line. Other people want it on a new line. Again, so you just want to agree so that you're consistent with your code, so that if I write a piece of code, it's going to look identical to, for example, if like Jack's writing code also, you shouldn't be able to tell ideally who wrote that piece of code if you're following style guidelines that are agreed to. Okay, so yeah, those are just a few ways that structurally you can improve your code. So again, we're talking about once you solve the solution, how can you make it better, right? So these are items that you should have in mind in terms of how you can improve your code. Just make it safer, future-proof it, and make sure it's designed in a proper manner. So that's where code organization is going to be highlighted today. So we're going to be talking about programming paradigms and specifically object-oriented programming. Again, it's a kind of a buzzy word. Short form is OOP. So you may have heard of it before, but note that there are other programming paradigms out there. OOP isn't the only one, isn't always the correct one to use. So functional programming is a popular paradigm that's definitely used often. There are a few others. I'm not going to pretend like I know what all these are. So there's procedural, structured programming, logical programming. These exist. That's my only point of putting on the slide. I can't speak to too much detail about these because I can't say I've done those too extensively, but good research project or a Google project if you want to learn about the differences about all of these and kind of what each entails and when you might want to use one or the other. But today's topic is going to be object-oriented programming, so that's what we're going to focus on. So let's, before I proceed, I guess, any general questions about any of these topics? So functionally, as I talked about, just improving your code, that's where we get into UI UX design, just making sure that your application is intuitive to your user. How many features are you providing? So that's what I mean by functionally, and algorithmically we touched upon, but just basically the execution speed and memory efficiency of your algorithm. Okay, so this is going to be, again, a lot of theory. This is probably the most theoretical slide. Fundamental features of OOP. So the only reason I included this is because this can be a popular interview question depending on when you're interviewing, especially if they incorporate OOP development. Then, more likely than not, they'll probably ask you about one of these concepts just to describe them. So I want to make sure that we highlight them, in just in case you get into an interview, you should be aware that these four features are core to OOP. First one is inheritance. So this kind of goes back to the DRY principle, the DRY, don't repeat yourself principle. Inheritance kind of achieves this by sharing similar features and attributes between similar objects. So this will make sense when we talk about classes. Basically, if you have two related objects, so let's say you have a dog and a puppy class, well, those are going to have very similar attributes. There might be some differences, but whatever they share should be shared in like a base class so that both of them can use the same logic rather than you having to create, an action for a puppy that a dog also does, right? Like they both may bark. So then why would you make it individual to each instance if they both do the same exact thing, right? So again, inheritance is just the idea of sharing similar attributes across different objects. Then we have this fancy word called polymorphism. I'm not a fan of like these scary sounding words because the concepts are fairly basic. So polymorphism is the idea that objects can take different forms depending on the context or the case that they're being used. This I guess feature of OOP is a little hard to kind of understand within Python because Python is dynamic already. So you don't really get to see polymorphism at play as it's just automatically done for you within Python. Other languages, it's a little more clear to see, like C++, polymorphism kind of is easier to spot when you're using it and when it's useful. Basically, again, just polymorphism is the idea that your code shouldn't really, I guess your objects shouldn't really need to be fixed to a particular box. They can kind of move between boxes based on how they're being used. So what I mean by that is, let's say we have a puppy class and a dog class. Well, both those are animals. So I guess both those, I guess, are canines, but both are also animals. So if you only care about the animal characteristics, you should be able to use like a dog object and a cat object in the same manner if you're only doing like animal related behaviors. Does that make sense? So they both can be treated as animals, but they also can be treated as, more specialized animals, which cat or dog. So that's where, again, polymorphism kind of allows that flexibility in OOP. The third feature we have is abstraction. Apologies. Abstraction is the idea that logic and complexity is hidden away from the end user. So what I mean by that is we talk about like a black box, where basically if I code up a module or some application and I hand it to you, you shouldn't need to know as a user of my application or that black box that I hand you, you shouldn't need to know what's in that black box. You should just know that what you need to input and what you get out as input are correct. So again, trying to give a good example here, but balance parentheses. Let's go back to our example that we did earlier today. You shouldn't need to know how I'm managing, the open parentheses. Like you shouldn't care if that's a list or if that's a dictionary or whatever data structure I'm using. It shouldn't matter to you as the end user of my balance parentheses algorithm. All you should care about is, hey, what do I need to input and what's the expected output? And is that output correct? Right? So that's your only concern as a client. Me as a developer, obviously, I know the complexity that I've put into that algorithm and that I wrapped up in, a function or a module that I'm handing to you. So again, abstraction is the idea that that black box should be self-contained and that it can do everything it needs to without the end user having to, know any particulars about it. And the final idea we have is encapsulation. Unfortunately, this is a little harder to see in Python specifically. Other programming languages do it better. I'm not quite sure why Python adopted, I guess, everything being public. But let's talk about what encapsulation means so that I don't lose you guys here. So encapsulation is the idea that data can be accessed only when needed, and that other, like certain data can be protected. When I say protected, it means not exposed to your end user. So we go back to the black box example. We provide an interface so that you can access like balance parentheses if that's something that I want to expose to the end user. That should be exposed to the end user, but the internal should be, again, protected as needed. So I guess a better example is, let's say I'm creating a user class. The user is going to have various properties on them, like it might be username, but also there might be a password that exists on the user. Usually you don't want to expose like password to the outside world, right? That's something that's sensitive. So that data should be protected within the user class. So if I created a class, I might have a method that says check against passwords so that I would input a password value and that function would check if that password value that I input matches the actual password for the user, and then should return true or false, right? We don't want to just spit out the password to the end user and say, hey, here's the password, check if that's correct, right? Because that's exposing sensitive data. So encapsulation is the idea that we should be able to protect certain data within our black box so that not everything is exposed. So again, Python is a little different in that everything that you put into a class is technically public, meaning anyone can access any data inside your class. Again, other languages like Java or C++, they have more specific layers of protection. So they have public, they have protected, and they have private. So private means nothing outside of that class can access it. Protected means only certain limited, I guess, areas of code can access it. And public just means, anyone using that class has access to the information. Okay, so that was a lot of technical terms, a lot of theory. Again, these are just buzzwords you'll hear. The main takeaway is don't be kind of intimidated by these fancy sounding words. The concepts overall are similar or simple. So inheritance, again, idea of sharing similar like data so you don't repeat yourself as a developer. Polymorphism, just the idea that objects can be flexible and can morph into, I guess, structures depending on the use case. Abstraction is just the idea of hiding away complexity from your end user. So your user shouldn't care how you've implemented your application. They should just care what it's doing and what the output is. And again, obviously you'd expect that it's correct. And encapsulation is the idea of hiding, again, specific data from your end user so that only relevant parts of your application are exposed instead of everything inside of it. All right, with that, I'm going to pause and make sure that everyone's kind of on board. Again, these are new terms. Just be aware that these exist and they're core fundamentals of OOP development. All right, hopefully I'm not putting you guys to sleep with that, but just be aware of these words, kind of Google them and kind of understand them better if you're prepping for an interview that's using OOP languages. All right, continuing on. Let's talk about classes specifically. So this is basically the core gist of OOP is creating classes. So what are classes? Classes are user-defined data types. So we've talked about data types in Python before, and I guess in JavaScript. So we have our base data types. So primitive data types include integers, booleans, strings. I think there's one more in there. But those are primitive data types. And then extending upon that, we have, I guess, I call them data structures, but I guess they're still regarded as data types in Python. So we have like lists, we have sets, we have dictionaries, we have tuples. So those are non-primitive data types. So I imagine all of these items as Legos. So this is like, you open a new Lego set, you have various pieces, like you have small pieces, big pieces. That's what Python's giving you. You have these Legos, which are integers or strings or dictionaries, whatever they may be. So that's what you get out of the box. But usually you want something, you want to build something bigger that's reusable. So you can take those base data members or, primitive, non-primitive data types that exist in Python and piece them together to make a bigger or more, more detailed data type for your own uses, right? So usually for applications, we're not just going to be dealing with integers or strings. We might be dealing with, a person that like a user object that has a username, address, other stuff. So that's all bundled together inside of a user class, for example. So classes, again, are just user-defined data types. The main idea here, again, is going back to that black box, is that classes bind data and data manipulation methods together. So again, if I have a user class, let's say I'm reflecting myself in the virtual world, I'm going to have a name. Let's say I have like a social security number. I probably have a birth date that's input there. So let's say, I need to change one of those. I guess you're not supposed to change your social security number. You can't change your birth date, but let's say I want to change my name, right? You're legally allowed to change your name. Well, the update for that name, the function should be contained within that class. You shouldn't have your end user having to do that manually to your data. Your data should be only updated ideally through the methods that exist on your class. And when I say methods, I just mean functions that live in your class. All right, so the data and the way the data updates should be kind of packaged into one box instead of kind of having those decoupled. The reason classes kind of make sense, just why it's like OOP is popular, is because classes are really useful for kind of representing real world objects in the virtual world, right? So when you think about, me as a person, I have properties and I have actions that I could do. That's kind of reflected when you create a class. Like you have properties, which are data members, and then you have actions, which are your methods that act upon that data. All right, so again, a lot of theory being thrown your way. Just kind of want to understand what classes are meant for and why they kind of just make sense from our coding perspective. So finally, the way to think about classes is that they're just blueprints. They're concepts. So if I'm thinking about a dog as a concept, I have a visual picture in my head of what maybe a dog looks like. That's based on an idea of a dog. So when I think about a dog, I think a dog usually has like a tail, has fur, barks, usually can play fetch. I don't know, whatever you think when you think about a generic dog, that is the blueprint of a dog. But then when you actually think of a particular instance, or what we use objects or instance interchangeably, but an instance of a dog is one particular dog that you're thinking of. So let's say you have a pet that that pet dog that you're thinking of is an instance of the concept of a dog. Does that make sense? So again, your class is a concept, and then when you create individual instances of that class, those are the objects you're creating. So we have a dog as a concept, but then when you create a particular dog, whether it be like Fido or Lassie or whoever, that's an instance of a dog class. All right, you guys with me still, or did I lose anyone along the way?
I'm still here.
All right. All right. Hopefully, again, not very theoretical. So just trying to get all the theory out of the way, but want to make sure we understand why classes exist and kind of how they are used within code. All right. So classes, main takeaway, they're user-defined types. They're created to create blueprints, and the blueprints allow you to create copies as needed, rather than having to recode the same thing over and over again. So imagine like a factory that's building whatever, it's building tables. Like that factory has a blueprint of how the table should be assembled so that it doesn't have to like resketch it every time. It knows what a table looks like and it can print them out when you need them. Okay, so going more deeper into what classes are, as we talked about. So classes only have two main sides to them. They have attributes and they have methods. So attributes are just data members or just variables that your classes have bundled together. So again, for a user class I might create, I might have a string that represents my name. I might have like a integer that represents my birth date. I might have maybe another integer or maybe a string that represents my social security number, whatever. So there's just various data members that I have within that class. Those are called attributes. So I might use these words interchangeably. You might hear them interchangeably, attributes or data members or class variables. These are all kind of the same idea. So attributes, again, are your data members, and then methods are how you manipulate those data members. So methods is just another name for functions. So we create functions. Hopefully we're familiar with functions in code. Methods is just a different name for functions that live within a class. So methods allow you to interact upon your data members, whether updating them, deleting them, doing whatever you need to do with your data members. All right, so that's basically it. Again, classes are pretty much that simple. You have data, and then you have functions that could update or manipulate that data. All right, so I think it's best to see an example rather than just talking about classes. So let's get to coding because that's more exciting. All right, so I have a coding window up here. It's going to create a class here. So if we look at our curriculum page, we have a very basic class. So let's talk about how we actually create a class. Okay, so to define a class, we actually just use a keyword of class. So this is a pre-reserved keyword. It's not a keyword that I made up. You got to use class, and then you can name your class. So naming conventions, we use camel case for naming classes in Python. So in this case, if I want to create dog, it's going to be capital D with dog. All right, so I have class dog, and then simply add a colon. And if I add a pass in here, this is the simplest class you can have. You have the class keyword, you give your class a name, and then give it some functionality. In this case, I put a pass statement, which just means this class has no functionality at all. And I've created a dog class. All right, so again, this is my blueprint. This is my idea of a dog in my application. To create an actual instance, so dog is a concept. If I want to create an instance, let's say I want to create Fido as a dog, I would actually create it by calling dog class. So dog is my class. Parentheses will create an instance of it, and then Fido will be my dog instance. So again, Fido is a particular dog versus dog, the class, is just an idea of what a dog is. Okay, let's actually make this a little more exciting. So I'm just going to copy the example we have here. Yes, I had most of it. So again, this is an instance of a dog. Let's actually print it out. It's not going to be too exciting. So if I print this out, we get this kind of strange looking output. We get main dog object at some memory address. So that's not really, again, I don't really care about this output. That's not useful to me as a user of this dog class. So let's jazz it up. So I'm going to copy our next sample and we'll go through, and again, a lot of this is going to be new stuff, so don't worry if you don't understand it right now. But let's make this a little more interesting. So I created a dog class. It has some data members. So that's what these are. They're just variables that exist within my class. I have some methods. So notice I have these methods. I have something called init. Strangely,
I
they
have a
have
question.
the underscores. Yep.
So for the assessment this week, because it's going to be in Python, we're going to have to create a class to successfully pass the assessment.
That is correct. So, yep, I know you. So we do have an assessment this Friday. So some of the aspects that we talked about, it is going to be coded in Python. We are going to ask you to write unit tests. So make sure you're familiar with unit tests. For assessment number 1, we are going to ask you to create a class structure, but it's not going to be too involved with classes. So it's going to be just a high level, do you know how to create a class? You're not going to worry about too many particulars within that class. But yes, you're going to have to deal with creating a class for assessment 1 this Friday. Again, so just the basics, you just got to know, use the class keyword, give your class a name, and then we're going to talk about like the init method and some other methods. But yeah, so my class currently has some data members and has some methods. So I have an init method. Again, we'll talk about why there's these underscores. There's this underscore str method. I have a speak method, so each dog can make a sound. In this case, all dogs are going to say woof. So this is an instance method, and we'll talk about what that means. But now that we have this, again, more interesting class, we can add more data to it. So I have a name that I passed to my dog class. I have a breed, so it's a pointer dog, and then I could call some methods on it. So if I do fido.speak, I would expect, I get woof as an output. Also, I have this description. So notice when I did print Fido, instead of seeing what I saw before, which was just an object. So how can I recreate that? I guess I could comment this out. So before, when I printed out, remember I got this, angle brackets, main dog, objects. Again, nothing that I really care about. But now that I have this str method, I get an actual description that's more useful to me. I'm a dog named Fido. My breed is pointer. I have 4 legs, and I say wolf.
So that's like toString in Java?
Sort of. So the print is going to try to convert this to a string. But yeah, so this str method gives that gives this class the ability to be represented as a string. I'm not actually too familiar with Java, so I can't give you a hard yes to that, but I believe it's a similar concept.
And the F in that that syntax is the interpolation kind of.
Yep.
Okay.
Yep. String interpolation. Just recap that. Yep. If you put an F before any string, that allows you to format it. So now I could have variables or some logic in here. So I could even do like +1 here. So I have a variable doing some Python logic within these curly brackets. But I don't want to add imaginary legs to dogs, so I'll leave that alone. Okay. So now we have this more detailed example. We're going to go through what this means, what these functions mean, what the self keyword means. Don't worry, we're going to get to that. I just want to show you guys kind of a more exciting class than what we had before. Okay, so if everyone's kind of good with what I've done here, let's actually talk about what I've added. So this is an example of a class attribute. So this is going to be an important concept for everyone to understand. Some students do struggle with kind of understanding why you need a class attribute or an instance attribute. Let's talk about that. So when you think about a dog conceptually, all dogs generally have similar traits that are shared, and all dogs have unique characteristics. So species is a great example of a shared characteristic. Any dog that you meet, as far as I know, again, I'm not a biology expert, but any dog you meet is going to have the same species, and that's Canis lupus familiaris. I don't know if I pronounced that correctly. Apologies to any biologists out there, but that's their species name. All right, so any dog you have, no matter if it's a pointer dog or a poodle or whatever, they have the same species. Again, their other biological representation might be different based on breed, but they're all the same species. So that's why this can be a class attribute. So that's the terminology I'm using here. Class attribute means that this particular attribute is shared among every dog that's going to exist. They're all going to have the same species. in my particular example, I'm going to assume that all dogs make the same sound. That might not be true in the real world. Like some dogs can maybe have some other barks, but I'm going to assume that all dogs generally, again, generally doesn't always have to be the case, but generally speaking, I'm going to assume that all dogs say wolf. So that's why I made this a class level attribute. And then also generally speaking, all dogs have 4 legs. Sorry, I should say that most dogs have 4 legs. Not every dog that exists will have 4 legs, right? I don't know if you guys watch those like YouTube videos of like, you know, some dogs that may have three legs that kind of hop around. Some dogs even have 2 legs, or, you know, who knows? There's different iterations of that. But for the general case, when you think of a dog, like a concept of dog, you think of 4 legs, right? I think that's fair to say. Are there any other like shared characteristics between dogs? Anyone want to add on here?
A tail.
Tail? Yep. Let's get a tail count in there. Let's say, you know, most dogs have 1 tail. I'm not sure if I've seen a dog.
Mammal, maybe.
What was that?
Is that a mammal? Sorry.
Yep. So we could say mammal. You can spell these correctly. Mammal. Is that right? No.
That's
That's right.
Is it? Okay. I'm not sure what's. Okay. Mammal equal true. Let's just make it a Boolean. It's not all animals may be mammals. Okay. Yeah. So we have some shared characteristics. All dogs are mammals, same species, etc. Then we get to instance attributes. So that's where the self keywords comes into play. So class attributes are defined just at the class level. So I create my class declaration here, and then inside of that, I just have all these attributes that are tied to the class. But then when I want instance attributes, they have to be tied to this self keyword. So I have this init method, and this init method takes in 2 actual parameters. Again, this self is a magic automatic parameter, so I kind of ignore it. But it takes in name and breed, the way I've decoded this up. So I'm actually going to take those values that are passed in and store that on the actual instance. And we'll talk about kind of what's going on here. But to back up a step, let's talk about this init method. So this is actually a special method. It has to be named in this particular manner. So it's underscore init, and then 2 underscores after it. This, again, it has to be formatted this way, and it has to be exactly named init. What happens with this init method is anytime you create an instance, this init method automatically gets called by the class structure. So I create, looking at line 18 here, let's get more space. On line 18, I create an instance of a dog, and I pass it a name of Fido and a breed of Pointer. These 2 values get passed to an init method like such. So I have name and breed. They're both strings, so they get passed as strings to name and breed. The self, again, the self parameter is automatically passed by the class structure. I am not passing self here. Notice I'm passing 2 string values that are going to be mapped to name and breed. The self is kind of automatically inserted there. What I'm doing with these values is I'm taking Fido, passing it to name, and then I'm taking name and attaching it as an instance attribute to that particular instance. So I know we touched upon this on maybe Thursday, but let's kind of make sure we understand what's going on here. So this self can be named anything you want. By convention, we use the name of self. Well, let's say, just to make this more clear, I'm going to name it to Fido. All right, so you can imagine, since I created an instance of Fido, that self is actually referring to Fido, which I've created on line 18. Again, when I call this dog class, it's going to automatically call this instance method and pass it Fido, because Fido is the object that's actually kind of calling that method. So now that I have this Fido here, I'm creating new variables on it. One is name and other is breed. This is identical to if I do something like this. I could do Fido.name out here and say Fido. This is the same thing. I'm creating a new variable, in this case, .name on Fido, and assigning it a value. So I could do that in my init method. I could do it outside my init method. Both accomplish the same task, but there's a reason why sometimes you do want to do it in an init method, and sometimes you might not want to. Just to clarify this point a little bit more, again, if I want to create a variable in Python, right, I could just declare it. So let's say I want to create a variable called x. I'm going to give it a value. there. I've created a new variable called x, and I've assigned it a value. That is the same exact thing that's going on line 19 as line 21. The only difference is this name variable or name attribute is only attached to the Fido instance. So x is kind of a global value. I can use it out here. I can't just use name out here. This name value doesn't exist outside of the scope of Fido. So it's similar if you guys want to kind of understand it in terms that we've talked about before. When you create a function, so let's say I create a function. Let's call it my function. Takes some nothing. So in this case, if I create a variable in here, let's call that y. This y value only exists within the scope of my function here. So that's sort of similar to what this name value is. This name value only exists when Fido is around. So Fido contains this name value, much like how my function contains this y value. Hopefully that kind of translates. So I could use y in my function, but I can't use it outside my function, right? So if I try to do print y here, I'm going to get an error because y does not exist in the scope. That's a little different than this, I guess, instance attribute in that I have access to it because like Fido isn't a function here. It's an instance of a class. So this name value is attached to it. And so long as Fido is around, I can have access to that name value. Again, that's similar to so long as this function block is alive, I have access to that y value. But as soon as this function is like destroyed or that block goes out of scope, I no longer have that access to that y value. So again, if Fido somehow went away, this name value goes away with it.
Ankur, I have a quick question.
Go for it. Love questions.
So I've noticed that on your line 13,
13.
because I'm writing the code as you're writing it, just so I can have the muscle memory.
Sure.
My self.legs and self.sound, it's saying that the code is unreachable, and I don't know why.
That is interesting. So my initial question would be, did you put a new line here?
I might have. Let me check.
So in Python, you can't. Yeah, in Python you can't add new lines. So if I do something like this, it's going to say this is unreachable, because again, in Python, white space is considered a delimiter. So new lines and tabs in Python actually give your code like definition. Versus in JavaScript, you can add new lines pretty much anywhere and it's gonna be fine. So if I do something like this, my code kind of gets dimmed out and it says code unreachable. I don't know if that's something similar to you.
Okay, so that fixed it. I just had to remove the new line.
Yep.
And then,
yeah. So if I had a new line here, yeah, this is gonna be dimmed out. Might be kind of hard to see on your screen, but since I added a new line, I'm gonna get unreachable code for that second line. Yep. So something keep in mind for Python. Unfortunately, you can't just add new lines for readability. Like again, it's tempting. Like yeah, this is wrapping around. I might want to make it more readable, but in Python, it's a little more difficult.
Yeah, it's hard to spot, but line 13 continues without it being on line 14.
Yep. Yeah. So yeah, there's this gap here. This line is wrapping because I have line wrapping on. That is a VS Code setting. I think you could have this go on off the screen if you want, if you prefer. But again, if I made my code window smaller, it shouldn't wrap. So this is technically one line just being wrapped. Okay. So again,
I have a question. Sorry.
no. Go for it.
So on line 8, when you change self to Fido, I'm a bit confused as to what that is actually kind of doing. Like what changes when you change that to Fido versus self?
Good question. So yeah, I've changed this to Fido, but this actually, again, this can be named anything you want. This is just a parameter to a function. So if we go to the function example, which I seem to have gotten rid of, when we have a function, right, you can name your parameters whatever you want. So if I want to name this whatever, this is fine. So whatever I pass to my function, so if I do, call my function with x. So I defined a value of x here, and then I pass x to my function. I can name this variable whatever I want, right? So I can name it whatever. I can name it x if I want, just to match what I'm inputting. I can name it donuts. It's up to me. Like usually, again, you want to use sensible names. So donuts is probably not a good representation here unless x actually represents like a count of donuts. But this, again, is a variable that I created and can name whatever I want. So in the same respect, this self value that existed before is just a variable that's being passed. So usually, again, by convention, we use the self keyword. Again, VS Code highlights self in a shade of blue just because it's a known, I guess, variable that's commonly used. But it's not, again, it's not anything special. In terms of self, you can use whatever you want, but we recommend self because that's the naming convention. So again, go for it.
But
Sorry,
it-
somebody else wants.
in this case, it's not being explicitly passed. So we know that the first argument is going to be the name of the subclass or function that's calling us. And so that's what's being used here, and self is commonly used to refer to that.
Yep. Yeah. So Don kind of mentioned there. Yeah, we're not explicitly passing it here. So this is some of the magic of classes. This self kind of just sneaks in there, and that's going to refer to whoever called that method. So again, for the init method, it's a little different because we're not necessarily calling a method. We're just creating a class instance. But if I do something like fido.speak, so speak is a method that I've created. So I have fido.speak, and this takes in the self. Again, that self is going to be Fido in this particular case, because Fido is the instance that's calling the speak method. So if I call Fido.speak, I can imagine that self really just is the value of Fido. So if I create a new dog, so let's say Lassie equals another dog. Does anyone know what breed Lassie is without me looking it up?
Go with Collie.
Collie? All right. I think that's how you spell Collie. All right, so if I create another dog, in this case, Lassie, it's a new dog separate from Fido. If I call Lassie.speak, now in this case, when I call speak, the self keyword is going to point to Lassie. So that's why, again, I want to keep it generic, but if I want to make this clear what's happening, when I call Lassie.speak, this self variable is pointing to the Lassie object in the case where I call Lassie.speak. For the Fido case, self is referring to Fido.
Okay, so that variable matters in the scope of those functions and methods within the class rather
Yes.
than outside of it.
Yeah, so that self, again, it just refers to whoever is invoking that function. So the instance that's calling this method is the instance that's passed to that method. So these are instance methods. So again, instances are calling this method, not, it's not like a, how do I say it? It's tied to an instance. So you can't just call the speak method from the dog class. You need a dog object to call the speak method. Sorry, hopefully I'm not confusing you guys there. But again, you need an instance. So when you think of a concept of dog, a blueprint, if I have Fido as an actual dog that's like running around my apartment, well, Fido can bark, but a conceptual dog can't actually bark because it's just an idea. They're not a real physical object when I'm talking about a dog blueprint or a dog concept. So when we create like a speak method, you need an actual dog to make that sound.
And in that case, you need to put self back in because Fido's not defined there, right?
Yep, absolutely. Yep. So again, self is just the default naming we use for that instance that's passed in. Because self can be anything. Self can be Fido. Self can be Lassie. You know, any dog that you create, that's what self will point to when you call that speak method. Okay, so just to back up one step. So we're creating instance attributes. Again, you can create it inside the init method or you create it outside of it. So in this case, we have name. Let's create a brand new variable. So let's say Fido has, let's say tricks. And I'm going to make this a list because dogs usually can know more than one trick. So let's say they know how to roll over, and Fido can also fetch if that's a trick. Okay, so we create a brand new variable that exists, like that's not in the init method. This is totally legit. Like you create as many new instance attributes as you want. So in this case, Fido has an instance attribute called tricks, but Lassie does not. Lassie apparently knows no tricks, which probably isn't true, but in my example here, Fido has tricks, Lassie has no concept of tricks. Like the variable, that instance attribute does not exist for Lassie at all. So this goes back to my point or my mention of sometimes it makes sense to create attributes inside the init method because these are guaranteed to exist for any instance you create. Versus if you create an instance attribute outside of the init method, these aren't guaranteed. So in this case, Lassie does not have a tricks attribute, but they both Fido and Lassie guaranteed have a name attribute and a breed attribute. So if I want to see what trouble I could get into, if I do Fido.tricks, okay, that's going to work. But if I do print Lassie.tricks, let's see what happens. So I'm going to save this, bring up my terminal. Again, Control tilde will bring up my terminal. And let's give this a run. So my file name is class.py. All right, so let's look at my output. So I got a woof from Fido, if I can find that code. So Fido spoke and said woof, and then Fido listed, I listed Fido's tricks, which are rollover and fetch. Then Lassie says woof down here on line 25. When I try to print out Lassie.tricks, notice I get an error. This dog attribute has no attribute of tricks. Okay, so this is, again, when you're designing classes, maybe you should have mentioned this from the get-go. Creating classes, it's kind of an art form. There's many ways you can technically do it, but there's generally a right way and a wrong way when you're designing classes. So it can be kind of frustrating. We're like, well, I'm achieving my objective, but maybe you totally missed the whole idea of object-oriented programming design. All right.
Hey, Ankur.
Yep, go
Another
for it.
question. So creating instance attributes outside the context of a class, is that it seems like that would be a bad practice, or there are use cases where you would do that because you've essentially taken the class and added attributes to some of the instances, but not others of the instances. So you've removed some of those OOP elements.
Right. Generally speaking, yeah, you're not usually going to create instance attributes outside of your init method. Sometimes you might. So I'm not going to say always that's a bad idea, but you're right. And so this is kind of getting ahead of ourselves. I think Thursday of this week, we're going to talk about inheritance. And it's one of those principles I mentioned earlier. But in this case, usually speaking, you probably want to create a new class. I'll call it Trick Dog. I don't know if that's a good name, but Trick Dog would have any trick dog that I create would have an attribute of tricks. So this is like a specialized dog that's beyond just the basic dog class that has a sound, legs, and a tail. Trick dog will have everything that dog would have. So this is where I would use inheritance, not God, dog. So in this case, if I created a trick dog class, sorry, I'm kind of writing all this code kind of messily. This trick dog would have everything that a dog class would have, but in addition to that, it would have, like, I would create an init method. Again, I'm going to lose some of you guys here, so I don't want to get too involved in here. But I would have tricks here. So I do something like this. So any trick dog I create would have tricks, but also would have a name and a breed. So in this case, I would call super. Again, I'm going to lose you guys here. I don't want to get too into this, but I think I do name and breed. So this would call the base class and pass it name and breed. All right, I'm not going to get into inheritance, but you're right. Usually, to answer or to echo what Sean was saying, usually you're not going to be creating instance attributes on instances outside of the class, but that's not always true. Sometimes it might actually make sense that you need to do that. But for the most part, you want to create your instance attributes in this init method. So just to recap, init is a special method that always gets called when you first create an instance of whatever class you're creating. So in this case, I'm creating a dog class. Notice I'm not calling init manually, but it implicitly gets called when I create this instance so that self.name and self.breed exists. So maybe I didn't quite highlight this. Let's do some print statements. So if I do Fido.name, that's an attribute that got created here, but exists on this Fido instance. Because again, self here is referring to Fido. So we do print that. I could do Fido dot breed. Let's get rid of last C over here.
Ankur, I have a question.
Go for it.
So is the init method like a constructor in other programming languages? Because it kind of seems like, okay.
Yep, you got it. Yeah,
Right.
constructor, you guys on C++, in JavaScript, we use a term called constructor, which, yeah, the init method is essentially a constructor, if you're familiar with that term. All right, so let's give this a run. Okay, so notice I got Fido, I got pointer. That's coming from my print statements. Again, so that's just showing that these attributes exist, even though they're created up here in the method. Okay, so Fido has a name, Fido has a breed. Lassie also has some stuff. Let's get rid of this code over here. All right, any other questions about what we've done here? So I guess I haven't talked about class attributes, or I have talked about them, but let's kind of highlight them. So again, Lassie has a name. So let's do Lassie.name. So again, we have class attributes. These are shared. So when I actually print something out, I could do print Fido dot, let's say legs. All right, so legs, notice I did not create an instance attribute of legs here, but I am essentially getting a legs value from Fido. What's going on here? So I call .legs. What actually happens is that the code looks for .legs as an instance attribute. So it's going to say, hey, does this Fido object have a .legs instance attribute? In this case, the answer is no. So from there, the code goes, okay, I'm not going to panic. I'm going to actually go up and check if the class has a legs attribute. So in this case, there's a legs attribute. So this is going to be fine. Will not be an error. .legs on Fido will be 4 because this is a shared value for all dogs. So if I do that and then do this.
Is it better to create your attributes as instance attributes or class attributes, or it depends?
It depends. So again, the reason that legs is a class attribute is because for the most part, all dogs have 4 legs. So I'm going to make that a shared attribute. Same thing with species. All dogs are in fact the same species. So instead of creating, a self.species here, and then adding in wherever this value is, that's kind of unnecessary. Again, is bad practice in terms of OOP design, because if every dog has the same species, then each instance doesn't need to have its own species record. You're just recreating that memory each time when it in fact doesn't need to be created each time for each dog. So again, legs, I'm doing .legs on an instance, but this is actually calling the class attribute because no instance attribute exists. So if I do a quick run of this code, notice I get Fido as the name because that's an instance attribute. It's unique to Fido. Legs is 4, and this is a class attribute. And this is, again, a shared value. Lassie, again, has a unique name, and it's an instance attribute because Lassie is particular to that dog instance, versus the legs is a shared attribute. Okay, so I'm going to create a new dog here. We're going to call this dog, can someone give me a good dog name?
Wishbone.
Spike.
Sorry. Spot. Okay, I heard Spot. So we have Spot, and Spot's going to be a special dog here. So I'll give name of Spot. I should probably capitalize these because they are names. Lassie and Fido. Spot, and then what breed will Spot be?
Dalmatian.
Dalmatian. Do I know how to spell Dalmatian? Is that right? Doesn't look right.
Yeah,
That's good.
Squiggled it for me. I gotta look it up. I think there's an I somewhere. Yep, T. Okay.
Do that early.
I was, yeah, not I-O-N-A-N. Dalmatian. All right. So Spot is a Dalmatian dog, but Spot's gonna be a little special. So unfortunately, Spot was running across the road and got hit by a car and lost a leg. So in this case, Spot's going to have 3 legs. Now let's kind of make sure we understand what's going on here. So let's move Spot to be above Lassie. And I'm going to do a print. Let's just do spot.name and print spot.legs. All right. Let's see what actually happens here. So notice line 24, I'm assigning to the .legs value. Question is, am I assigning to this value, which is a class value? So the question is, or I keep saying question, am I actually updating the class level attribute such that all dogs are going to have 3 legs now?
No.
No way.
Yep. I mean, I wouldn't want to, but let's see if I'm actually doing it. So let's look at our output. Notice I have Fido has 4 legs. Spot has 3 legs. Lassie still has 4 legs. So in the order of our code, I have, I assigned to dot legs on line 24, but Lassie comes after it and is using a dot legs, but that's still 4. So what's actually happening here? So this is a case where we're creating an instance attribute. So again, these dogs, Lassie and Fido, they don't have an instance attribute of legs, so they default to the class level attribute because that's the common case. So I've decided that legs is a class level attribute. So since I didn't specify that on Lassie nor Fido, they're just going to default to 4. What this is doing on line 24 is actually creating a new variable. So again, we've talked about you can create new variables on the fly. So in this case, I could say spot dot happy equals true. Again, I've created this brand new instance attribute that only exists on the spot instance. So I named it happy in this case, so that's a new value. The only difference for, maybe keep that around, for line 24 is that legs is the exact same variable name as the class level attribute. But that's okay. So this, the term here is that you're overriding, so writing, R-I-D-D-I-N-G, you're overriding the class level attribute with those instance level attribute. So instance attribute gets priority over class level attributes. So when I said, when you do Fido.legs, it's actually going to search the instance and see if .legs exists. If it doesn't, then it's going to go to the class level. So in this case, for Spot, we actually created an instance level attribute so that when we try to read Spot.legs, it checks the instance first and says, okay, Spot actually has an instance level attribute named legs, so I'm going to use that one. If it didn't find it, it'll go to the class level attribute. This is all making sense?
Ankur, I have a question. So that would be like the parent and child class, right?
No.
Oh, I'm sorry. I might have gone way down a rabbit hole with that one.
No, that's fine. I'm glad you asked it. So when you talk about parent and child classes, that's again going to the concept of inheritance. So parent classes will be your base class, and then child classes are stuff that gets everything from your parent and then might be specialized some more. But yeah,
that was like the trick dog thing, right? Was when we touched on.
Yeah, so when we created a trick dog, in that case, trick dog would be considered a child class of the dog class because it should inherit everything the dog can do, but then add on some more functionality. But again, we're getting into inheritance on Thursday, so don't worry if, again, you've never heard of inheritance, that's fine. You're not behind the game at all. Okay, so we talked about, again, instance level attributes, class level attributes. It's very important that you guys understand when they make sense. So again, just to highlight, species is the best case here because all dogs are the same species. All dogs are mammals. So this doesn't need to be defined on the instance level. It can be, as in this will go back to the point I made before, as in you can have it on the instance level and your code will totally work fine, but that doesn't mean you've designed your code in the appropriate manner. Okay, so maybe the best way to highlight this, let's say some biological breakthrough happens. Actually, I think this happened when I was doing my research of the name of the species. Let's say we actually realized that dogs actually have a different species name for whatever reason, like they derived or evolved from some other species, and that changes the name. So in this case, let's say I have Lassie, Spot, and Fido. If I need to make that change, I can simply do it here. So let's say the new species name is just canine. That's not a species probably, but if that's the new name, I made that change in one place, and that's going to apply to all 3 dogs because they're all sharing the same data because they're the same to all of them. However, if I created a instance level attribute called species, now I would have to change this for all dogs. Like if I were passing it in, so let's say I was passing in species here. I don't know what the species was before, but if I'm passing that value in for each instance, well, then I'm going to change it for each instance here. I guess technically you could hard code it, as in I could just put in species goes here. So in this case, it'd be similar to what I did before, as in one central place, but still each dog has its own copy of it, and it really shouldn't have that copy of it. All right, likewise, let's say we go to some alien planet and, all dogs there have 5 legs. Well, this dog class, let's say we want to use this dog class. Well, we just change it because all dogs now have 5 legs by default. Okay, so again, class level attributes are shared between every instance of the dog for the most case. Again, legs is a good example of, typically all dogs, the idea of a dog, when you think of a dog, I would assume typically think of some animal that has 4 legs. But that's not always true. We've seen dogs that have, fewer than 4 legs. I guess theoretically they might have more than 5 legs if they have some, birth issue. But for the most part, most dogs or all dogs have 4 legs. There are exceptions. In this case, Spot will be that exception. Any questions on instance attributes versus class attributes? It's a very important concept to understand. Again, when you're designing classes, you want to make sure that you're following proper OOP design principles.
I don't have a question about those, but what kind of method is the __string __ method?
Glad you asked that. So let's continue on with our lecture. So again, we covered class attributes, instance attributes. Just to go over this one more time. Class attributes are shared properties between different instances. So different instances of dogs will have the same species name, same chromosome count, etc. But different dogs will have different names, different ages, etc. So anything that's unique to a particular dog, that's going to be an instance attribute versus anything that's shared between, basically all dogs, that's going to be a class attribute. Next up, we have Dunder methods. So this is what John was asking about. So if you guys are Office fans, hopefully you guys can appreciate that. But we have something called Dunder methods. So those are those weird __, methods that I kind of introduced without quite talking about them. They're, again, I don't know why they're called Dunder methods, but other names for them might be special methods or magic methods. But Dunder methods is a terminology for Python classes. So let's meet the Dunder methods. So we saw a couple of them. There's a whole list of them. So there's init, there's string, there's also repra, which I've never really used, but it's supposed to be similar to the string method. We have equals, addition, dictionary. There's so many more. Let's actually do a quick Google if I can find my browser. So list of every Dunder method Python. Reddit post. Let's try holycoders.com. Hopefully they're reputable. All right, so I'm just going to scroll through this. I'm not going to go through it, but there's a whole bunch of them. All right, so this looks like a dozen here, maybe another dozen. There's at least 30 different methods, Dunder methods, and they all do something that you might want to override. But I'm just going to talk about a few of them. If you're curious about all the ones that exist, you could definitely Google them. But let's talk about why these exist. So these are built-in methods that you get when you create a class. So again, a class is a structure. In Python, you get these methods kind of automatically. So in init, if you don't create an init method, that's okay. There's going to be a default init method that just exists behind the scenes. Init is our constructor. So again, this method is a special method that it gets called automatically when you create an instance of your class. So if we go back to our coding example quickly, this init method automatically gets called whenever I create a dog instance. Right? So I'm not calling init myself, but the class framework or the structure of the class automatically is going to call this init method. If I name this something different, if I name it like, x init, this is not going to work anymore. So if I try to run this, notice it's thinking that dog has an init method that takes in no arguments because it didn't find that I created my own init method. So it's going to think there's a default init method that it's using that takes in nothing. So this is actually what it created. This is the default init method. If you don't create one, this is what it's going to use. So this takes in self, which is that automatic parameter, so it doesn't quite count. Returns none, has no functionality. So that's the error I got because I didn't properly define my init method, but I was passing values to my init method that's going to get invoked. So again, this has to be named exactly __init __, because that's a default method that Python is going to look for when creating your class. So that's what the init method does. Again, constructor, if you're familiar with that term, it's just the very first method that gets called when your class is getting created. The string method, I didn't quite talk about it, but that's something I had defined here. So this is just to give your object some representation in string form. So when I call print, so I think I did that earlier. When I call print Fido, normally Python doesn't know how to output Fido. Like Fido is a data type that it doesn't know how to output, right? when you output, like an integer, it knows how to output that because that's pretty simple. When you give it a dictionary, if I create a dictionary here, right? So if I create a dictionary, Python knows how to output a dictionary because it's like a native type. So if I do my dictionary, it can accurately represent that because it just knows how to do that by default. But by default, it doesn't know how to represent your dog class. It can't just say, okay, well, I know that you have a name value, so I'm just going to show that. Like Python is not that smart. It just sees some data values, doesn't know how to output them. So it's just gonna, if I don't have the string method, if I add X here and print out Fido. Sorry, let me get rid of some extraneous outputs. All right, clear this and run python.class. Okay, notice I get, again, this is what I was getting initially. I get some weird output, like I get dog object at some memory address, not very helpful for my needs. That's why we usually create string methods so that as users, we can see like a good representation of our class. So in this case, I defined an str method. And now that I have this str method here, whenever I do a print, it's gonna invoke this str method. So if I run this again, oops, that'll be my terminal. Notice I get, a good descriptive output. That's all coming from this str method. All right, so that's another Dunder method for classes. It has to be named __str. You don't have any control over the naming for these functions if you want them to work the way that they are. So these are reserved names, and Python will look for these specific names when they're trying to do specific actions. So in this case, it's trying to print out an object and convert it to a string, so it looks for the str method. We have repra, which again, I've not used. I've read up on it. It says repra should be a string output for your class versus str is like an informal output. So again, I don't have a good way of distinguishing those two. I always use str. Repra again is just used in other cases, but str is the only one that I've used, and it's fine. Again,
it's a result rather than string, which is a description.
Yeah, I mean, if I had repra, then I could just simply do Fido here, and that'll print it out. Or maybe I need to be in my Python shell. Regardless, don't worry about repra. It just exists. Know that much. str will get you through our needs here in terms of representing the objects in a descriptive manner. We also have, again, a whole list of other ones. Some that I want to point out. There's EQ. So this is the test for equality. So this gets invoked when you do something like, all right, let's bring back our other dog friends. All right, so I could do something like if Lassie equal Spot. All right, I can actually compare dogs with each other. Again, normally Python doesn't know how to compare two dogs to each other. So it's going to default to its behavior, probably compare like the memory addresses of this and check if Lassie is actually the same object as Spot. But you can actually override that if you have an EQ Dunder method. So if you want to see this, let's quickly create one. So again, some of this is going to be reading documentation. So if I EQ here, I'm going to have a self parameter and then an other parameter. Again, this is reading documentation and understanding what's required here. So other, let's call other dog. So I can just return false by default if I don't want two dogs to be equal. But let's just say if they're the same breed, let's just consider the dogs equal. So if that's, for whatever our condition is, if we want to say same dog breeds are equivalent, other dog breed. All right, so in this case, just be double equals. We have this equal method, and it's going to check, hey, is the current instance equal to the other instance breed? If that is true, we're going to return true from our equal Dunder method. If not, it'll be false. So in this case, I'm going to change, let's see. Let's make Fido, what do I have here? Lassie and Spot. Let's make Spot collie also, all right? And then Fido can remain a pointer. So in this case, if I do equal with Spot and Lassie, this should be true because we've manually defined what our equality case is, right? So this, again, comes down to what your application needs to do. it might make sense that the breed being equal makes your dogs equal. Maybe not. It's up to you. So this is true. Let's just say Lassie and Spot are the same. And then we can also do, if Lassie equal Fido. Okay. I know we've been going a long time without a break. We're approaching lunch, so I'm just gonna power through the next 15 minutes. So if you guys can stay with me. But all right, so we have Lassie and Fido. All right, so these are equal. These should be printed out. So let's kind of clear up our console here. Okay, so I have Fido, which is a pointer, and then Spot and Lassie are the same breed. And according to my logic, I've said same breeds can be considered equal. So if I run this, clear and run this. All right, notice I only get Lassie and Spot are the same. And this whole check is coming from here. So if I didn't have this EQ here, so let's just put an X here. So again, this is no longer a special Dunder method. I just put an X in here, so that's just some random method I've created. So if I run this again, notice I get no output. That's because this equality is going to default to the base, the base case of Python, which is it's going to check, are these two objects actually the same object? So the only way this would be true is if I actually assign Lassie to equal Spot. So now that both these are pointing to the same exact dog, so if I ran this now, notice I get equality. That's what equality does by default. It checks if the objects are identical, as in the same exact object. But that's not what I want to do here. I want dog breeds to be my equality case. So that's why I have a special EQ method. Any questions on Dunder methods? Okay, again, there's a whole list of them. You can have add. So this kind of overrides the plus operation. So normally, if I try to do something like print Lassie plus Fido, again, Python has no idea how to add two dogs together, as in dogs in the sense of the class I created. So I'm not even sure what's going to happen. It might kind of error out. Let's actually find out. So let's get rid of some output here. Let's see what happens here. All right, notice we got unsupported operands. Python's like, hey, I have no idea how to add one dog to another. That's Python just like throwing up its hands saying, what are you doing to me? But if I want to give this some functionality, let's create a add method. So again, this is back to reading documentation. Just got to know that __ add is maps to the plus function. So I do self, and then it's also going to have an other dog. Let's return. All right, let's actually create a new dog. So what is happening here? Well, two dogs are getting together and they're making a new dog. That's it's covered in Platoon's biology bootcamp if you're interested, but I won't cover that here. But it's going to create a new dog. Let's give it a name of name and breed of. Let's actually say it's going to be the breed of the dog from the current instance. Let's make this a little more. Let's say the name of the new dog is going to be the combination of the names of the parents. So self.putAdog. All right, so now I've implemented this Dunder add method, and I've given functionality to, sorry, this should be name. So I have other dog, which is, I guess, the right side of this equation, and then the left side is the self. And that actually matters. The order of that will matter. So if I do this, self is going to be Lassie in this case, because Lassie is first here, and Fido is going to be the other dog. So in this case, the dog name will be a combination of the two dog names, the two parents, and the breed is just, I'm going to default the breed to be, I guess, the left parent. So now that I have this add method, I can actually print out Lassie plus Fido, because I also have this str method defined. So let's actually see what gets printed out here. Notice, okay, so I am a dog named Lassie Fido, and my breed is Collie, because Collie was Lassie's breed. And then I have 4 legs, and I say wolf. Okay, so we just implemented functionality for this plus operator when Python by default had no idea what to do with it. So again, this is highlighting the power of classes. So one thing I maybe should have mentioned early on, a lot of the stuff you can do can be just done with dictionaries, right? If I want to quickly try to do this, let's say Fido, I create a Fido dictionary. I can do this, right? I can create a name key and then give it a name. So name would be Fido. I could say breed is, I think I had pointer. What else do we have? We have legs. That was a class level attribute in our class way, but in this case, we have legs here. I'm not going to add all of them, but we had tail also. And then I also think we had like mammal. Okay, so this, I can totally create like a sort of a representation for a dog using a dictionary. The question is, why do we prefer classes over dictionaries? Well, we've kind of highlighted some of the reasons. One is we could have class level attributes, so these are shared. So if I need to create like a Lassie dictionary, I would have to copy this, create a Lassie dictionary, and then change the values. So Lassie has a different name. Collie, I think we said, and then these three are the same. So now we're getting, again, we're kind of violating our dry principle where we're repeating ourselves. We have these values that are kind of shared, but in this case, since we have a dictionary, they're not actually shared. I'm recreating that data over and over each time. So again, another advantage of classes is that you can have that shared data so that if we reach Mars and realize Mars actually has dogs with 5 legs, I don't have to go through all of these instances and change those. All right, another benefit of classes that we just touched upon are these Dunder methods, right? So now, if I wanted to add like Fido with Lassie, that's not possible here. Like it's gonna be really complicated. I could still create a function that kind of combines the values I want. So I could basically, what I'm doing in this add method, I could create a function for it that takes in 2 dictionaries and extracts the values. But when you think about it again conceptually, like thinking about a dog or a person or whatever you're trying to represent, a dog is an object that has properties on it. A dog is not just a simple key value paired thing, right? It's not just something that has, name and a name value and a breed value. It's actually a real object, like a dog running around my apartment has properties and can do actions. Those actions will be methods, and the properties are the data members in my class. So the whole point here is, yes, you can use dictionaries to accomplish pretty much anything you need to in Python. But that doesn't make it the right design. So we're talking about improving our code, making our code better. So just because you can achieve it doesn't mean it's the right approach to it. Any questions on kind of what I said there? Does everyone kind of understand, when you should use dictionaries and when you should not use dictionaries?
Yeah, so I guess just to kind of make sure I'm on the same page that you are, you'd be missing out like on a lot of the power behind Python if you chose to use dictionaries when you can actually use a class separately to like as a base case.
Yep. So again, classes, just to mention what we said before, classes are really useful for mapping real world objects. Real world objects have properties and I guess can do actions. Dictionaries do have their place. Like sometimes it makes sense to store data in a dictionary if it's just key value pairs. Dictionaries, again, you don't always want to just say, hey, I'm going to throw this into a class. Sometimes it does not make sense to use a class. When there's just simple data members you're trying to keep track of, like if this was like a phone book and I just want to keep track of, a name and, phone number, I might just default to a dictionary. If I don't need extra data. Again, if it's a person that has more properties, then I might consider, okay, if it's more beyond just like, key value pairs of names and phone numbers, like I want to keep track of address and other stuff, I might probably branch out to a class at that point. So kind of understand what tool you need to use for the particular job at hand. All right, so Dunder methods, another advantage of classes. You can do some special things with Dunder methods. Okay, so there's a few more. There's dictionary. I guess I could quickly highlight that just for fun. So these underscore methods, you can call them manually. You usually shouldn't, but you can. So dictionary is one that can be useful. So if I do underscore dictionary, again, this is a Dunder method. Takes in no parameters. And let's see what it outputs. So actually, let's do it for Spot, because Spot's a cooler dog. What did I do here? Okay, it's not Dunder methods. Okay, so sorry, I guess dictionary is not technically a method, but gives me a representation of the dog. So notice I just call it dictionary and it gives me a dictionary representation of my class. So again, this can be useful if you need it. We can talk about CSV files later today. This can be useful when you want to kind of write out classes out as values to a file. But yeah, again, these magic methods exist. You guys can Google all the ones that exist, and you know, you probably won't use most of them. I've not used most of the ones beyond here. For the most part, init and string are probably 95% of the Dunder methods I've used in my lifetime. Okay, where we leave off. Okay, key takeaways. Let's kind of wrap this lecture up and get to lunch. Again, apologies for going an extended session without a break, but a lot of takeaways here. One is just understand what object-oriented programming is. The idea is you're creating blueprints and creating objects from those blueprints. And the idea is you create multiple copies and different copies of a concept that you have. So it just makes it easier, again, when you're thinking about dogs or whatever object, like if you're gonna have multiple dogs, you shouldn't have to recreate the wheel each time you're creating a dog object. So when I was creating dictionaries, I was basically recreating like a dog object or a dog data each time. Versus classes, I already have that blueprint kind of set, and I can use that factory to print out as many, you know, dog instances as I want. Again, classes are used for mapping real world objects. So again, you know, me, I'm a person, I have properties attached to me, like, you know, eye color, hair color, height, weight. So those are properties that exist to me as an instance. And they're not, again, how do I kind of explain this? So those things don't exist outside of me. So that's why it wouldn't make sense to kind of just have, okay, like a function that says, hey, you pass me a name and I'll give you like the weight for that person. You can, like you hard code that, but that's kind of breaking apart me as a person. Like weight is part of me. It's not just some value that's associated with me, if that makes sense. Since I exist, my weight exists, my height exists, my eye color exists. So again, coupling data together, bundling things together into a package. So again, going back to the black box example, when I hand you a person class that has my, you know, that's representing me, it's going to contain my name, it's going to contain my eye color, my hair color, social security number, whatever is represented in that class. And then, you know, you can use that person object and kind of use it for your needs. You shouldn't have to worry about the implementation inside of it. Know how to create a class in Python. Again, we kind of went over this, but class keyword, give it a name. Parentheses here are optional. So if you are not inheriting from anything, you can leave off these parentheses. Again, we'll talk about inheritance on Thursday, so don't feel like you're lost or anything, but simplest class, class dog, and then some implementation. Difference between a class and an instance. We've talked about this. Just to repeat it one more time. A class is an idea. It's a concept. It's a blueprint. An instance is an actual manifestation of that class. So of that idea. So dog as a concept, I think about, you know, 4 legs, a tail. When I create an instance of a dog, I'm like, okay, I'm thinking about Lassie. Lassie is a collie that has a name Lassie. I think, you know, blonde fur, can do various tricks. Like that's an instance of a dog versus a dog concept. So hopefully, you know, I've said that many times. Hopefully I haven't bored you guys with that, but I just want to make sure that's clear. Last thing, class attributes versus instance attributes. Know when to create which. So if something is shared between basically all instances, so if all dogs have a very similar characteristic, whether it be species, or number of legs, or, you know, that they're all mammals, that is a class level attribute you should create because it's shared. It's a common property between all dogs. But most objects have unique characteristics. Me as a person, I have a unique, you know, hair color. When I say unique, like individual to me, like obviously there's other people that have black hair or might be my height or my weight, but that's, you know, that's dependent on the instance. It's not something that's shared by all instances of humans. Yeah, for dogs, again, dogs have different names. They usually know different tricks. So whatever is individual to a dog, that's an instance level attribute that you would create when you're creating your class.
I have a question.
Go for it.
In an interview, if you wrote class with the parentheses and it was empty, would they laugh at you? Be like, you should know that. Implicit.
I would hope that no interview would ever laugh at an interviewee. I don't think it's not, they're not going to penalize it for you. It's making it clear that there's nothing being passed to it. So I wouldn't deduct anyone for putting parentheses there. if you feel more comfortable putting parentheses there, just because sometimes you need them when you have a base class or multiple base classes, yeah, I don't think that's wrong. But I've never technically interviewed for a Python specific role, so I'm not sure how people would actually take that. I think it's fine. So yeah, small being figured out. I don't think anyone would care too much.
I also have a question. So I guess just for readability wise, when we're I think you had mentioned earlier that we will be this week's test will include like a class kind of test. Would it be like a good practice to, I mean, just for readability, like while we're going through each of these challenges, to host our class files separately from our actual challenge and then import it that way?
I am so glad that you mentioned that, because that's something I definitely wanted to talk about. And in my attempt to get finished before lunch, I totally spaced on that. So I'm so glad you mentioned that. As a side point, unfortunately for my Zoom view, I can't always see like the raised hand symbol. So if you guys have a question, just feel free to, ask away. But Kyle made a great point, and that is, I think, the last point I want to end on. I know we're at key takeaways. Yes, file organization. That's another part of making your code better. You don't want to just toss everything into one giant file. That's going to become unmanageable and just kind of hard to work with. So yes, usually the rule goes, each class that you create should have a separate file. Now this isn't 100% always should do this, but for the most part, new classes should be in different module files. So let's actually clean up our code a little bit. So I'm going to create a new folder. I'm going to call it animals. Inside that animals folder, I'm going to create a dog.py file. And I'm actually going to move my dog class into there. And yeah, this is proper design. So this is what we kind of expect you guys to do. Kind of separate your pieces into modules. Again, break it down to smaller units. So when we talk about, creating functions with separate logical units, same thing with files. You want to kind of have files specific to what data they contain. You don't want to just have one file that has your entire application when it's using multiple components. Yep. So I created a dog.py module file, put my dog class in there. In my main file, which is called class.py, I want to import that. So to import that, I'm going to do from animals, which is my folder. So it's like a submodule. And then I have dog. I'm going to import my dog class. All right. So hopefully you guys are getting familiar with the syntax for importing items. So now let's say I create a new cat class. I know there's probably some cat owners out there. I'll create a new file instead of nesting it, instead of putting in my dog class, which wouldn't make sense, or my dog file, I would say cat.py. You could do class cat. In this case, my cat's not going to have any functionality. So that's a simple class. Again, this class exists, so now I could use it here. So I could do.
It's a very appropriate cat.
I guess, yeah, some cats are very inactive. So I can do cat, Garfield, and I need to import it still. So I'll do from animals, cats. But yeah, this makes your code much more organized, much more cleaner. Again, Kyle, yeah, definitely glad you asked that question. Great question to ask, and definitely we are gonna look to make sure when we do grade you on code style for your assessments also. It's not gonna be like majority of your grade, but there's some component of code style. Have you named stuff appropriately? Have you broken stuff into functions appropriately? Have you, made modules as in separate files appropriately? So yep, that's something that that we will definitely be asking for, and just again a better something to get in the habit of when you're coding is to break it down into smaller pieces. The reason being is, let's say I had a different file that needs to use my dog class. Well, now it could freely use my dog class without worrying about anything that's in my class implementation. So if I have like a main.py here, and I only want to use, like, let's say I only use my cat class. Well, then I could just totally ignore dog in this case and include only cat here, right? Now my application or my code is more modular. So I can only use the things that I care about. In this case, I only want to use a cat class, and I'm ignoring dog in this file. All right, great questions as always, guys. Any other final thoughts, questions, concerns about classes before we break for lunch? Okay, you guys are gonna get a ton of practice going with classes, so don't worry if you're still kind of fuzzy on it. Obviously, it's easier to kind of learn things by doing it rather than listening to a lecture. So let me stop the recording here.